Welcome to this explainer. Today, we're diving right into the hidden plumbing of the internet. You know, if you've ever wondered how billions, literally billions of devices manage to talk to each other without the entire global network just completely melting down, well, it all comes down to the architecture of network traffic. Specifically, we're looking at network switches and routers. Sure, in a server room, they might just look like identical metal boxes with blinking lights, but as we'll see, how they process traffic, how they segment networks, and how they handle broadcast domains, it's like night and day. Let's get right into it. So here is our roadmap for today. First, we'll look at local switching and collision domains. Then we'll cover the Layer 2 broadcast flood. And finally, we'll wrap up with routers and broadcast domains. Okay, to really understand how these devices work, we first need to draw a hard, absolute line between two completely different ways networks identify devices. Over on the left, you've got Layer 2, the data link layer. This is all about physical, permanently stamped hardware IDs called MAC addresses. Think of it like a car's VIN number. It's stamped on there at the factory, looking like that long string of letters and numbers, a colon BB. Now, on the right, we have Layer 3, the network layer. This relies on logical, assignable network IDs, which you definitely know as IP addresses, like 192.168.1.50. This is more like your home's mailing address. It can easily change if you move. The big takeaway here, switches live over on the left, and routers live firmly on the right. All right, part 1. Local switching and collision domains. Let's see how we manage the neighborhood. So back in the day, before modern switches, networks relied on these chaotic old hubs. It was basically a free-for-all where everyone just shouted over each other. If two devices tried to send data at the exact same millisecond, you got a literal data collision, hence the term collision domain. It was a complete mess. But switches, they completely revolutionized this whole setup by operating at Layer 2. Instead of that chaotic hub, modern switches actively segment these collision domains. They literally give every single port its own dedicated connection. That means the PC plugged into port 1 and the PC in port 2 can blast out data simultaneously, and they won't interfere with each other at all. It's brilliant. So, how does a switch actually direct this local traffic? Well, when your PC sends data to another PC on the exact same local network, the switch makes this incredibly fast 1, 2, 3 forwarding decision. First, it looks at the destination MAC address on the incoming data frame. Second, it checks its internal MAC address table, also called the CAM table. You can just think of this table as a map showing exactly which device is plugged into which port. And third, it shoots the frame directly at the specific port where that receiving PC is hooked up. Quick and easy. But notice what's totally missing from these steps? A router. For this local neighborhood traffic, a router is never even approached. The switch handles the whole shebang. Moving on to Section 2, the Layer 2 broadcast flood. This is what happens when everyone needs to hear. Because look, sometimes you just don't know exactly who you need to talk to in your network neighborhood. When a device needs to reach out to the entire local subnet all at once, it uses the Layer 2 broadcast MAC address, which is just a wall of Fs. When a Layer 2 switch receives a frame stamped with this specific address, it treats it like a massive digital shout. The switch literally floods that frame out of every single other active port, forcing every single device in that local segment to receive it and process it. Now, you're probably thinking, wow, that sounds incredibly noisy and super inefficient. And you're not wrong. But this wide-reaching broadcast flood isn't some kind of glitch. It's an absolutely essential mechanism. Really critical protocols literally depend on this to function. Take ARP, for example. It uses this massive broadcast shout to hunt down a physical MAC address when a device only knows the logical IP address. Or DHCP. It uses this exact same flood to basically yell, hey, can someone please assign me an IP address to the network? So we actually need this noise. But here is the massive architectural problem we run into. Because a switch blindly floods these broadcasts out of every single port, it creates one gigantic shared broadcast domain. So we really have to ask ourselves, if every switch on Earth just kept flooding these noisy broadcasts to every single connected device, how does this escalating avalanche of noise not just spill outwards and completely crash the entire global web? Which brings us to Section 3, routers and broadcast domains, or as I like to call them, the Network Border Patrol. Remember earlier when we talked about how switches segment collision domains down at Layer 2? Well, Layer 3 routers are the heavy lifters that step in to segment these massive, noisy broadcast domains. See, routers do not care at all about those physical MAC addresses. They actually strip away the physical MAC info so they can make their routing decisions based strictly on logical IP addresses. They are operating entirely up at Layer 3. And the crucial point here,
The thing you really need to remember is this. A router interface acts as a strict, hard boundary. It flat out refuses to forward standard Layer 2 broadcasts. When that incredibly loud digital shout of all Fs hits a router port, the router just drops it. Boom, done. This absolutely guarantees that the broadcast noise generated over in Segment A stays permanently, safely trapped in Segment A. There is zero chance of it crossing over into Segment B.
So think of the router as our absolute network border patrol. A switch will only ever escalate a frame up to a router if the destination IP address of that data packet is actually trying to leave town to visit a completely different subnet. It's a really great division of labor. If the traffic is just local chatter, the switch handles it. But if the traffic is destined for the wider internet or an entirely different logical network, it gets handed over to the router to cross that strict Layer 3 boundary.
As we wrap up this explainer, we've seen how switches expertly manage the local traffic and completely eliminate those old data collisions, while routers stand guard as the strict borders that stop broadcast floods from basically taking over the world. But I want to leave you with this final thought. If routers are the critical, strict, logical boundaries keeping total internet chaos at bay, what exactly happens to global traffic when these borders are misconfigured? It's a pretty fascinating question, and it really highlights just how delicate and perfectly balanced our network architecture truly is. Thanks for joining me on this explainer, and keep learning.